All right, let's get into it. Today, we are going on a journey. We're going to start with the numbers you use every single day and go all the way, all the way, to the mind-bending giants that live at the very edge of mathematics.
So really, how high can numbers go? It sounds like a simple question, right? But let me tell you, the answer is so much more astonishing, so much stranger, and frankly, more magnificent than you could ever imagine. It really pushes the limits of what we can even wrap our heads around. So let's start our climb somewhere familiar. These are the numbers that have a real, tangible place in our world, from the cash in your wallet to the stars up in the sky. Okay, let's kick things off with 1,000,000. It sounds like a lot, but let's put it in perspective. If you were to start a timer and just wait for 1,000,000 seconds to tick by, you'd be waiting for about 11.5 days. Totally manageable, right? You could do that.
Now, how about 1,000,000,000 seconds? This is where our brains start to warp a little. See, 1,000,000,000 seconds isn't just a few weeks or months. Nope. It's over 31 years. That is the staggering leap from 1,000,000 to 1,000,000,000. All of a sudden, it's a huge chunk of a person's life.
And then, 1 trillion? This is where we pretty much hit the ceiling of what we can comprehend in our daily lives. $1 trillion? That's the scale of entire national economies. 1 trillion miles? That takes us way, way out into our galaxy. It's a number we hear about, for sure, but can we truly feel it? Probably not. Okay, you ready? We're leaving the comfortable foothills behind us. It's time to climb the Ilian ladder. And on this climb, the numbers grow at a truly explosive rate. Visualizing them? Yeah, that becomes pretty much impossible. Right after 1 trillion, we slam into the quadrillion.
And then, right after that, comes the quintillion,
Followed by the sextillion. With every new name, we're just slapping on another 3 zeros. The scale is it's exploding with every single step we take up this ladder.
And this whole system, it just keeps on going. You've got names like dixillion and undixillion, and it goes all the way up to vigintillion. That's a 1 followed by 63 zeros. And believe it or not, that is nowhere close to the end of the list. But here's what's so cool. There's actually a secret behind these kind of crazy-sounding names. They're not just random. They're actually based on a pretty simple Latin code. Quad means 4, quin is 5, dec is 10, and vigint is 20. It's this hidden, totally logical system for naming the unimaginably large.
So now we're leaving those systematic Willians behind. We're entering a whole new realm, a place where numbers were invented pretty much just for the sake of being enormous. These are the true celebrities of the number world. First up, the Google. That's a 1 with 100 zeros after it. Just to give you a little context, the total number of atoms in the entire known universe is estimated to be around 10 to the 80th power. A Google is just vastly, vastly larger than that. It's not even a competition.
And the story behind the name? Oh, it's just brilliant. It really shows you the human side of all this math. It wasn't dreamed up by some serious committee. Nope. It was invented back in 1920 by a 9-year-old kid. His uncle, a mathematician named Edward Kasner, just asked him to come up with a name for a ridiculously big number.
So if you thought a Google was big, you need to meet its big brother, the Googleplex. It's not just a 1 followed by more zeros. It's a 1 followed by a Google of zeros. And here's the part that'll break your brain. You could not physically write this number down. I'm serious. There isn't enough matter in the entire universe to make the ink and paper you would need. It's a number so huge, it's really more of an idea.
And this, my friends, is where things get truly, truly wild. We're now moving beyond numbers that you can physically write out. We are entering a space where numbers are less about counting and more about defining the very boundaries of a mathematical idea itself.
Say hello to Graham's number. This thing is so massive, it makes a Googleplex look like a tiny rounding error. Our normal ways of writing numbers? Totally useless here. It needs its own special up arrow notation just to be described. But what's so fascinating is that it wasn't just created to be big. It actually came from a field called Ramsey theory, which, put simply, is this beautiful idea that complete chaos is impossible. That in any system that's big enough, you're guaranteed to find some kind of order.
And just when you think, okay, that has to be the absolute ceiling, you find out about tree 3. This number comes from a totally different area of math called graph theory, the study of networks and connections. And it is so incomprehensibly larger than Graham's number that even trying to compare them is, well, it's almost meaningless. The scale just keeps rocketing up into pure abstraction. And finally, we get to Rayo's number. Now this one's different. It's not just some big number. It's a number that's really about the limits of our own language. In simple terms, it's the smallest number that's bigger than any number you could possibly describe using a specific set of rules with less than a Google's worth of symbols. Just think about that for a second. Its very definition is about the boundaries of our ability to describe things.
So after that journey, from a couple of seconds to a number that's literally defined by the limits of language, what does it all mean? What have we actually been looking at here?
Have we really been climbing some infinite ladder of numbers, or have we just been bumping up against the walls of our own imagination? Maybe the whole quest for the biggest number isn't really about the number itself. Maybe it's a quest to understand the incredible power and, yeah, the profound limits of the human mind.